experiment in finding good information from crowdsourced surveys on Amazon Mechanical Turk. Alright, so after we gathered our 5,000 data points, we ran clustering algorithms on it using dbScan. We were able to find a Python implementation of dbScan online, so we just plugged our information into it. We experimented with different numbers of pins and clusters. Since we generally ran about 20 surveys for each image, we started off with like 7 to 10 pins per cluster. We tested as low as 5, as high as 15. But the way we ran our experiment is that we kind of just randomly put out images and had people survey them. So we don't have an even distribution of these surveys. I think our lowest was 15 experiments for one image, and our highest was like 30. So some images can't possibly have clusters of more than 15, or one, at least one. For a range of clusters, we kind of set arbitrary values. We tried 35 pixels, 50 pixels, and 75 pixels. And you'll see our results of those numbers later.
Alright, so the data formatting is very simply, it's called an IDAF file. I'm not entirely sure what it's actually called, but I know it's Google's like standard format for feeds, for data feeds. And the way that it's set up is it's a key delimiter, attribute delimiter, value delimiter. So the way that we have it up is our image tile, our x and y coordinate for that user's input, and then what cluster number that pin fit into. If it didn't fit into a pin, obviously there would be no cluster number there. Our database with all of our results was dumped into one giant CSV file that we're going to push, so that all of this data on all of the IDAF files and all of the heat maps we generated, everything will be open source, viewable, editable. You know, you'll be able to see it, do whatever kind of research you want to do on it if you're so inclined. Going back to all of our data, approximately 1% of it was bad. Some images didn't load correctly. Some users, submitted information with blank images. I'm not entirely sure, but about 1% of it, so that's pretty good. So I guess our results are the crowd found 1,876 houses overall. And that was using a minimum of 7 pins per cluster and a minimum pin radius of 50 pixels. It's about 35 feet. And I'd say that most houses are, within 35 feet of one single point. The average user's grade was about 66%. The way we gathered this information was for one user, we counted the number of results they submitted, and we counted the number of results of these pins that fit into clusters, divided it, averaged every single user's grade, and we got about 66%. This makes a lot of sense, and it validates kind of these numbers, because other groups that have research crowdsourcing get about 33% of the data as bad data, and these numbers make sense physically. 35 or 50 feet is a good, house radius, and that makes sense. Here is more of a graphical implementation of that. The bigger the bubble, the bigger the radius we use to cluster. That bottom x-axis is the number of pins per cluster, so you can see that as we increase the number, as we required more pins for the clusters, less users' pins were in there, obviously. And so, the general trend is as you move up, the accuracy drops. The one that we were looking at is right there. So that's, 66%. So also what this experiment generated was what was it, 12,000 by 12,000 image heat map with all the pixels on, represented by dots. The crowd is very scarily good at finding out where houses are at. I don't know if you could see this too well, but pretty much every single house is like nailed here. And it's just like right on the spot. There are very few like extraneous points. This is down to a ½ foot resolution. All the tiles were scaled at resolution, so you can continue to zoom into this and get even more accuracy. And we got all of these points for 50 bucks in less than 24 hours back. So this is kind of along the SOPA Act, or like the government finding stuff out about you, or people finding stuff out about you. It's very plausible, very easy. If this is what two college students can do for less than 50 bucks for online, then what can anybody else do? So I guess that's it. You know, if you want to play around with our data, check our GitHub. You know, it's not that interesting, but if you are so inclined and you get bored over, you know, winter break with nothing to do. So, all right, thanks a lot, guys. Any questions? Yeah.
How big of a plot is this of land?
8,900 feet each way.
Okay, so like roughly a little
mile and a half?
square miles. Yeah.
Yeah.
Where did the pictures come from?
Colorado, where I'm from. So this is like a half a mile from my house.
Is it like a satellite?
Yeah.
Satellite
And
image?
actually, it's a high resolution ortho imagery. So the United States Geographical Service continuously flies planes over areas to get aerial imagery for places, and it's all online for free. This is all public domain, so very easily gotten, grabbed, and figured out. Cool. All right, let's get out of here. Last day of classes.